The surface of the moon is composed of lunar regolith, an unconsolidated layer of material that covers the lunar surface. Lunar dust and soil are the finest components of this regolith, while larger fragments, commonly known as moon rocks, provide much of the scientific data. The oldest of these rocks offer valuable clues about the moon's origin and the structure of the materials formed eons ago. Formed more than 4 billion years ago, the moon may have played a key role in the development of the Earth. But here's where it gets mysterious. Could these ancient rocks hold the key to understanding why Earth has oceans? It was well known long before Apollo 11 that the moon was a barren rock, but that didn't mean that it didn't play a critical role during the earliest days of Earth. We're in what's known as the Goldilocks zone, a rare condition where everything comes together to make a planet hospitable to life. Earth is so far the only planet we know that can sustain life, and there is one factor that determines that more than any other: water. The chemical compound of hydrogen and oxygen that makes up Earth's water is fairly rare in the universe. Many of the other planets discovered to have oceans possess seas more akin to a chemical soup, undrinkable or outright toxic. Yet that water has to come from somewhere, a question that has driven some of the most intense astronomical research for decades. And for half a century, scientists thought they had the answer. They were wrong. It's not known exactly how long water has existed on the Earth, but evidence suggests it was present long before the moon formed. Around 4.5 billion years ago, a massive impact created the moon, vaporizing much of the Earth's surface and shrouding it in a thick atmosphere of rock vapor. This occurred well before life emerged, as the first single-celled organisms appeared between 3.7 and 4.1 billion years ago. Somehow, after this cataclysmic collision, conditions aligned to create the perfect storm for life to take hold. Could a single impact really have set the stage for life as we know it? This period coincides with an era known as the Late Heavy Bombardment, a time where the solar system was experiencing a much higher rate of astral impacts. This would have spelled the end for any life on the Earth if it existed. The planet was constantly rocked by massive explosions, its surface a churning fiery landscape. Yet, rather than being destroyed, Earth was forged by force. Countless heavy bodies slammed into the planet, delivering new elements from the depths of space and shaping its still-forming surface. And one of those elements might have been water. The prevailing theory holds that Earth's water arrived from impacts with objects from elsewhere in the solar system. Mercury and Venus couldn't hold on to it, scorched by their closeness to the Sun. Mars may have briefly sustained oceans, as evidence of ancient riverbeds suggests, only to then lose its atmosphere and with it chance for life. Earth, however, formed oceans and a stable atmosphere, setting the stage for everything that followed. But what if that story isn't the full truth? The University Space Research Association has kept possession some of the moon rocks over the decades, as well as a healthy supply of finer lunar regolith. While research on this material is highly regulated due to how critical it is to keep those objects intact, the investigation into its properties continues. And a research team led by Dr. Tony Gargano recently examined a large collection of lunar samples using high-precision triple oxygen isotopes that allowed for a clearer look at the molecular structure of the rocks. And their results reveal more questions than answers. The truth may lie in the structure of the moon and what it can reveal about the Earth. While our planet appears stable, it is anything but. Tectonic plates shift constantly, slowly destroying and remaking the surface. The Earth that was bombarded by meteors and comets during its formation is long gone, leaving no record of what those impacts delivered. The moon, however, tells a different story. It is airless, static, a ball of rock that has remained largely untouched for billions of years as it orbits the Earth, and that makes it a perfect time capsule. Each rock collected is a miniature archive, preserving clues about the moon's formation and composition. Despite the differences between the Earth and its satellite, many of their features were shaped by the same cosmic impacts. And now scientists may be closer than ever to unlocking its secrets. Using these unique isotopes, scientists examined the molecular makeup of moon rocks and lunar regolith, gaining far more insight than earlier technology had allowed. They confirmed the presence of metal-loving elements commonly found in meteors, revealing just how much of the moon was forged by massive impacts billions of years ago. But their primary target was hydrogen, and proof that these impacts delivered water to the solar system. And they did find it, but not how they expected. NASA scientists now have the most complete picture of the molecular makeup of the moon rocks they've ever obtained. They did find hydrogen elements, but not in the quantity that they expected if the meteorites were a major contributor to the existence of water in the solar system. Because the moon is frozen in time, the hydrogen in its rocks mirrors what likely arrived on the Earth as its first oceans and atmosphere were forming. And that tiny mismatch is shaking up everything we thought we knew about where Earth's water came from. If this was the amount of water that made it to the Earth from meteor impacts, likely carried by ice, the odds are heavy that it would have evaporated quickly. The Earth wouldn't have had the chance to create an atmosphere or form oceans. This complex chemical process that forms water, cycles it through the atmosphere, and returns it to the Earth would have never begun, meaning life itself might never have taken hold. Which raises a question that has haunted scientists for decades. How did it all start? These findings have forced the scientific community to reconsider the origin of the Earth's water, challenging the decades-old meteor hypothesis. While hydrogen in lunar samples once seemed to support the meteor delivery theory, modern analysis tells a different story. The amounts now detectable suggests that meteors were unlikely to be the primary source. If they had been, the moon's surface would be very different today, perhaps even resembling the wetter ancient landscapes seen on Mars. And that means that scientists have had to look elsewhere. This is the ultimate mystery in a way. Why are we here? No water, no humans, and the search goes on, with scientists turning their focus to similar explanations. Meteors and asteroids are the largest impacts that can happen to a planet, reshaping the surface at will. The largest impact after the creation of life on the planet resulted in the dinosaurs being wiped out, and the fear of another one that could end human civilization persists. But they are far from the most common projectile within the galaxy. Comets are also flying through the galaxy, but they're not composed of rock. They are primarily made up of dust and ice, and as such, they have a much higher level of water in them. When they hit a planet, it's more likely to cause surface-level damage and disintegrate upon impact. This leads to the space dust dispersing and the water soaking into the surface and contributing to the presence of water on Earth. The age of heavy impacts on the Earth likely brought countless comets to it, and there would have been little trace of them left. Still, the evidence suggests the answer lies somewhere else entirely. Samples of comets have been analyzed for a long time, and while there is the presence of the core components of water, the molecular balance is off. It has a much higher presence of deuterium, an isotope of hydrogen that is extracted from water. This doesn't match up with the chemical components of water on the Earth. Additionally, the number of comet hits needed to create the stable level of water we have on the Earth would be monumental. It's currently estimated that less than 10% of the Earth's water comes from comets, which means we might have to look closer to home. The meteor theory was the prevailing one for several decades, as these massive celestial bodies were large enough to carry enough ice to change the ecosystem of the Earth forever. But new evidence suggests that while meteors and comets contributed, they likely weren't enough. This has revived the idea that the water may have originated on Earth itself, without much outside help. A difficult possibility, since much of the planet's early existence was far too hot to sustain liquid water. Yet even as the Earth struggled to cool, the universe around it was anything but quiet. One leading theory suggests Earth's water was delivered by planetesimals, icy primitive objects that collect in gravitational fields like the asteroid belt. These celestial building blocks are thought to have bombarded the early Earth and the Moon, potentially acting as the delivery service for the vast oceans we see today. The unsettled universe would have produced countless such objects, and over time Earth's gravity gradually pulled them in, adding to the planet's mass. The water they carried would have delivered the bulk of the Earth's water, slowly building the oceans as we know today. But that led to another question. Some scientists skeptical of this theory point to differences in noble gas ratios between Earth's atmosphere and mantle, suggesting they may have originated from separate sources. This has led to speculation that much of the Earth's water arrived long after the Moon formed. Since less than 1% of the Earth's mass arrived after the impact, it would have taken an enormous amount of water-rich material to create the oceans as we know today. And so it might all come back to that big impact. The most recent hypothesis gained traction after a 2019 study of molybdenum isotope ratios, and new evidence continues to support it. According to this theory, most of the Earth's water arrived after the Moon-forming impact, but it didn't land here as liquid. Instead, the intense heat of the early planet kept it in a gaseous state. As Earth gradually cooled, this water condensed and rained down over eons, eventually filling up the oceans we know today. And in the end, the answer may be more complex than anyone imagined. Perhaps it really is all of the above. The story of how water arrived on Earth grows more complex every day because new evidence keeps emerging. Advances in technology now allow scientists to examine Earth's surface and lunar rocks with unprecedented precision, revealing the chemical building blocks of our world. It seems likely that water arrived in massive meteor impacts as well as smaller comets and planetoids. At the same time, Earth's atmosphere may have formed naturally, cooling around the molten planet. Together, these forces combined to create the unique ecosystem we call home. And even after 50 years, these rocks may still have secrets to tell us. Secrets that could rewrite the story of Earth itself. The mysteries of our universe are just starting to be unlocked. Check out what NASA actually found on the edge of the solar system, or watch this video instead.